Okay, today we're going to keep talking about some geometrical figures. Today we're going to talk about three-dimensional figures, or what we refer to as solids. So we've talked about polygons. Polygons are closed figures created by a finite number of sides that meet only at their vertices. Um, in the three-dimensional world, that translates kind of to what we would call polyhedrons. A polyhedron is a solid with all flat surfaces that enclose a single space. Okay, so you can see a lot of parallels here between polygons and polyhedra, or yeah, polyhedra, polyhedrons. And the first is that they enclose a single space, right? So there's only one space inside. It's not divided into two. It has to have all flat surfaces. That's kind of like being made up of line segments. It can't have any curves to it at all. Obviously, it needs to be closed. And then there are different parts to the polyhedron that we're going to talk about, those being the vertex, which would be places where corners where line segments or edges meet, edges, which are the line segments making up each of the polygons, and then the faces, which would be the flat surfaces themselves. That arrow's a little bit misleading. And so the vertex are the corners, the edges are pretty self-explanatory, the edges, and the faces are what we call the sides. You're definitely going to want your formula sheet as we go through today. There's going to be quite a lot of formulas that would be very handy to put on your formula sheet. So if you don't have that, make sure you pause and get that real quick. Okay, there are two basic types of polyhedrons that we're going to talk about, a prism and a pyramid. A prism is a polyhedron that has two parallel congruent faces. We will call those bases, and then they are connected by other faces that are all parallelograms. So we have two bases, they're opposite each other and they're parallel. In this case, they are both pentagons. They are these guys. These are the bases. And then the parts that connect them are all parallelograms. In this case, rectangles. The other type is what's called a pyramid. It has a single base and then sides, triangular sides that are come along the edge of that base and then join at a single vertex up top somewhere. It's the biggest difference between prisms and pyramids is the number of bases. If it has one base and then all the sides or all the faces meet at a point, it is a pyramid. If it has two bases that are parallel and the edges are all connected with parallelograms, then it is a prism. So some other solids that are not polyhedrons would be a cylinder. It has two bases that are congruent and parallel, but those bases are circles, so they are connected with a curved surface. It breaks the definition of a polyhedron, but it is an important solid. The pyramid version of a cylindrical prism, if you will, is a cone, a circle, and then one curving face that connects all the edges of the circle and points to a single vertex. And then a sphere, which is pretty self-explanatory. A sphere has no faces, edges, or vertices. It is completely smooth. The definition of a sphere is the set of all points that are, excuse me, the same distance from a given point. So whatever the center is, if I had a string of 3 inches long, let's say, the sphere would be made up of all of the points on the space that the end of the string can touch, no matter where I move it. That would create my sphere. So polyhedrons, or like I said earlier, polyhedra, are named by the shape of their bases. So here we have two parallel sides, so we need to first find the parallel side. So it takes a second of looking sometimes, but you'll see that these triangles are the parallel sides. They're congruent and opposite one another, and they're parallel. So because those are the bases, it's going to be a triangular prism. You can see that the sides that connect those triangular bases are still rectangular, right? Parallelogram faces connecting the two bases. This one's a little bit tricky because it has lots of pairs of opposite bases. So what that means is it doesn't really matter which sides are the bases at all. So this could be one of the bases, and then this would be the opposite. Or we could say that this is one of the bases, and this is the opposite. Or we could do the front and back. It doesn't really matter. The rest of them become the faces that connect them. But either way, the shape of the base, no matter which pair you choose, is going to be rectangle. So it's rectangular, and it's a prism because it connects two bases. Same idea here, but our two opposite bases are pentagons. And then they're connected by our rectangle. So this is a pentagonal prism. Now on the other side, we have our pyramids. They all join at a single point. It's pretty easy to recognize a pyramid very quickly. Then naming that is just based on what the shape of the base is. So this is a triangle, so it's a triangular pyramid. This one's a rectangle, so it's a rectangular pyramid. This one's a pentagon, so it's a pentagonal pyramid. You can go hexagonal period, septagonal period, you can keep going. But we name the prisms or pyramids based on the shape of their bases. And that's important to remember. So 3 questions for each of these solids. Are they polyhedrons? How many faces do they have? And how many vertices do they have? Let's label the questions A, B, and C. So for this first guy, is it a polyhedron? Yes, it is. How many faces? Well, it's got the 2 bases, which, because it's rectangular, could be any, but let's say it's this big top one and the bottom one. So it's top and bottom, and then 4 sides, making there to be 6. Oops, so yeah, that's a yes. And B, 6 faces. C, how many vertices do they have? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 vertices. This would be a rectangular prism. All right, the second one. Is it a polyhedron? No. It has curved surfaces. It's still a solid, and we can still know a lot about it. It still has a lot of interesting features. We're still going to do calculations and use formulas based on a cylinder, but it is not a polyhedron. And then finally, is this a polyhedron? This is yes. This is a triangular pyramid, right? Meets at a single vertex, base is a triangle, triangular pyramid. How many faces does it have? Well, there's the one in the back that we can't see, this standing up triangle. Then there's these 2, so that's 3, and then the base, so that's 4. How many vertices? Well, there's 1, 2, 3, 4. Okay, you're going to want to put this in your notes. A polyhedron is regular if all of its faces are regular congruent polygons and all of the edges are congruent. So that means that not only do all the sticks that make up this shape need to be the same length, but all the sides, like if this were a box, all of the sides needs to be exactly the same also. So we can have either a pyramid, a cube, or these 3, which we'll talk about in a second. These are the only 5 types of regular polyhedra. There are only 5. So a die, like a regular die for a game, is an example of one. It's called a cube, or if you want to name it based on its sides, a hexahedron, because it has 6 sides. We can have a tetrahedron, which has 4 sides. Those will all be equilateral triangles. 6 square faces for the cube. In an octahedron, you can have 8 equilateral triangles. It's like taking, well, yeah, two square pyramids and putting them base to base, kind of. A dodecahedron, which has 12 regular sides, and those are pentagons. Or an icosahedron, which has 20 different equilateral triangular faces, but each one of those triangles will be congruent. Each one of the pentagons in the dodecahedron will be congruent. So these are the only 5 shapes that you can create that would be fair dice, if you will. Right, if you want a 4-sided die, it's going to be a tetrahedron. It's going to be a triangular pyramid where the sides are the same shape as the base. If you want a 6-sided die, it's going to be a cube. That's just like the ones you've seen. You can have an 8-sided die by making it an octahedron, a 12-sided die by making it a dodecahedron, or a 20-sided die by making it an icosahedron. But if you want any other number of sides, the die won't be fair, which means some of the sides will be bigger than others, making them more likely to be landed on. These are the only 5 regular polyhedra that are possible. They're called platonic solids because the great philosopher and mathematician Plato used and wrote about these shapes quite a bit, which means he figured out thousands of years ago that these were the only regular polyhedra. Pause this if you're not done copying these down, otherwise I'm going to keep moving. So surface area is defined as the sum of the areas of all of the surfaces. So we're going to go through kind of shape by shape here and write down the surface area formulas for each of these solids. Then we're going to go back through with some of the volumes. Okay. I'm not going to do a lot. I'm just going to kind of talk through the formulas and explain what some of these values that it's referencing are talking about. So for a prism, surface area is equal to P times H. Well, P is the perimeter of the base. It's the perimeter of the base times the height, so that's the distance between the bases, plus 2 times capital B. Capital B is the area of the base. So we have to add 2 base areas, which makes sense. And then we need the area of all of the connecting faces. So if we do the perimeter times the height, if you were to unfold this right here, imagine cutting along this dotted line and unfolding that box, kind of. We would create one giant rectangle out of all of the sides. So that would be just the perimeter times the height to find the area of that rectangle. So this finds us our vertical faces, and the 2b finds us the area of our bases. For a regular pyramid, it is 1/2 the perimeter of the base. Anytime you see a capital P, it means perimeter of the base. Anytime you see a capital B, it means area of the base. So the only new thing is this lowercase l, and that means the slant height. The difference between the slant height and the height of the pyramid, height of the pyramid is from the center, and it's literally how tall the pyramid is. The slant height is along the edge of the pyramid itself, and it's the height of the triangle that is leaning over, because we need to find the area of that triangle. So we're going to use that height, right? So 1/2, this is basically the perimeter stands in for base in the 1/2 base times height formula for triangles. But instead of doing base there, we'd have to add up 4 of them. We're using perimeter because that's all of the bases of the triangles times the height of the triangles times 1/2 will give us the area of the triangles plus the area of the base for that capital B again. Again, pause if you're not done. I'm going to keep moving. So cylinder and cone. Surface area of a cylinder. Let's start with that. Surface area of a cylinder is 2 pi r. We recognize that, right? The 2 pi r is the I'm sorry, 2 pi r squared will be the area of the bases, right? 2 pi r squared, because pi r squared gives you the area of one base. We double it, so it's going to give us the height of 2 bases. And then the 2 pi r h is going to give us the area of our vertical piece, this kind of curved section. Because if you unfolded this curved section, it would just be a giant rectangle, right? So imagine cutting along the edge here vertically and then pulling it out straight. It would just be a rectangle. H would be one dimension of that rectangle, and 2 pi r would be the other. 2 pi r is circumference, right? So we're taking the circumference, which is this length, and multiplying by the height to get the area of that piece, and then adding it to the area of the base times 2. For a cone, it's similar to a pyramid. We have pi r times the slant height. So here's where we're going to see height and slant height. L is the height of the cone as if you measure the edge of the cone. And then the pi r squared is the area of the base. Okay, so surface area of a cone is pi r times the slant height plus pi r squared. Surface area of a sphere. So the surface area of a sphere is 4 times pi r squared. We're going to talk a little bit more later about where this formula comes from, because this one's not quite as easy to see. But 4 pi r squared is how we find the surface area of a sphere. Volume is the other formula that we often use in three-dimensional geometry. Volume is defined as the amount of space contained by a solid measured in cubic units. So how much stuff could each of these shapes hold? For a prism, it's just the area of the base times height. It's like we're taking the area of one of the bases and then just stretching it up by multiplying by the height, and that will calculate all of the interior space. For a regular pyramid, it is 1/3 area of the base times the height. So what's interesting is if we made a rectangular prism out of this instead of a pyramid, the pyramid would take up 1/3 of that box. The empty space would be 2/3. So area of the base times the height for the volume of a prism, area of the base times the height times 1/3 for the volume of a regular pyramid. Now notice we're not going to do multiple shapes of pyramids because this area of the base kind of covers that. This is the same formula for a triangular pyramid or a hexagonal pyramid. It's just that calculating the area of the base gets a little bit more tricky based on the shape. But this is the same formula. It's just finding the area of the base that changes with the shape of that pyramid's base. For a cylinder, the volume is, again, the area of the base multiplied by the height. But in this case, excuse me, the area of the base is a circle, so it's pi r squared times h. So pi r squared times h is the volume of a cylinder. For a cone, much like a pyramid, it's 1/3. So if you make a cylinder into a cone by connecting these sides instead, the area contained or the volume contained by that cone is 1/3 the area contained by the cylinder, which is kind of interesting. Otherwise, it's the same formula, pi r squared h, but then times 1/3. It's kind of cool that these have the same relationship that the prism and rectangular pyramid do. Same formula divided by 3 for any shaped base, even when that base is round. So even though it's not a polyhedron, it still follows that same principle. And then finally, the amount of space contained by the solid measured in cubic units for a sphere is 4/3 pi r cubed. Again, we will talk more about this one later. The spheres formulas are probably the most difficult to derive, meaning to see where they come from, but it's not impossible. So the volume of a sphere is 4/3 pi r cubed. It needs to be cubed because we need to have cubic units to represent space. All right, so let's try one. Find the surface area and volume of this rectangular pyramid. Okay, so surface area is going to be area of the base plus 1/2 perimeter times the slant height, right? The height of the triangle. So let's start with there. Surface area. Area of the base. Well, this is 6. It looks like it's going to have to be square. There's no other way for us to know what the other lengths are, so we'll assume that that's a square pyramid. So that's going to be 36 centimeters squared, right? Because 6 times 6 is 36, plus 1/2. The perimeter is going to have to be 6 plus 6 plus 6 plus 6, or 24, times the slant height, which is this one, because it's the height along the edge of the, or along the face of the triangle, the height of the triangle, not the height of the pyramid. So the surface area is 36 plus 12 times 5, or 60. Surface area is 96 centimeters squared. Make sure the units reflect what we're measuring. Volume of a rectangular pyramid is 1/3 area of the base times the height. Now this is the height of the triangle, so this is the 4 that we're going to want. So volume is 1/3 times the height, or 4, times the area of the base. So again, that's just going to be the 6 times 6, or 36. So volume is 1/3 of 36 is 12. So 12 times 4, it's 48 centimeters cubed. Good luck with the homework. Let me know if you have any questions, and have a great day.